This is lesson 15 Pythagorean theorem video. We're going to talk about informal proofs of the Pythagorean theorem. You've already watched a little bit of the video, so we know what the Pythagorean theorem is, and we're going to practice using it to find the length of the hypotenuse of a right triangle. Just as a review, we have two parts to the right triangle. We have the legs and we have the hypotenuse. Remember, the legs of the right triangle are the two sides that together form the right angle. So these would be our legs. The hypotenuse is the side that is opposite of the 90-degree angle, or the right angle. So in this case, our legs are the sides that measure 6 and 8, and our hypotenuse is the side that is called C. We've also found that there is a special formula. The Pythagorean theorem states that for any right triangle, we can find the side lengths of the triangle by using this formula. A squared plus B squared equals C squared. So if we look at our example here, A can be represented by 6, B can be represented by 8. So A squared would be 6 squared plus B squared would be 8 squared. That equals C squared. And as you look over here, you have the steps to solve and find that C actually equals 10. If you look at this one, let's look at example 2. We're going to determine the length of the hypotenuse. Okay, so we're going to write A squared plus B squared equals C squared. Okay, we're just going to write that in because now we're going to substitute in values for A. A, let's substitute 3. So 3 squared plus B, let's substitute 7. So 7 squared equals C squared. 3 squared is 9 plus 7 squared is 49 equals C squared. 9 plus 49 is 58 equals C squared. And now we know that 58 is not a perfect square. So we're going to go ahead and use a calculator and find the actual value of 58 squared, the square root of 58, because the inverse of squaring a number is taking the square root of the number. So when you find the square root of 58, you know that 58 is a perfect square in between the perfect squares of 49 and 64. So it's going to be between 7 and 8. Let's take it to the nearest hundredth place, so that's 2 decimal places, and we'll round it. And so we're going to say it's approximately 7.62 units. We don't know what our units are, so we're just going to call it units. We don't know if it's yards, we don't know if it's feet, we don't know if it's centimeters, so we'll just say units. Okay? We're going to work through a couple of example problems together. We're going to determine the length of the hypotenuse. Okay? So we're going to use the Pythagorean theorem. So A squared plus B squared equals C squared. A, we're going to substitute in 3 squared plus B, we're going to substitute 4 squared equals C squared. 3 squared is 9 plus 4 squared is 16 equals C squared. 9 plus 16 is 25. So 25 equals C squared. So is there a number that I can multiply by itself to get 25? Or you could take the square root of 25. We would find that 5 equals C. So C equals 5 units. Okay, let's move on to example 2. We're going to find that A, we're going to do again Pythagorean theorem. So A squared plus B squared equals C squared. What number are we going to substitute in for 8? Or A? 8 squared plus what number are we substituting in for B? 11 squared equals C squared. 8 squared is 64. 11 squared is 121 equals C squared. 64 plus 121, do it mentally. 4 plus 1 is 5. 6 plus 2 is 8. And 0 plus 1 is 1. Equals c squared. 185, not a perfect square. So 185, and the square root of that is about, so c is about 13.6 units. Okay, last one we're going to do together, then you'll have 2 more to do independently. Okay, again, we're using the Pythagorean theorem. So a squared plus b squared equals c squared. Substituting 4 in for a, so 4 squared, plus 9 in for b, which is, so 9 squared, equals c squared. 4 squared is 16, plus 9 squared is 81. That equals c squared. So let's add this together mentally. 6 plus 1 is 7. 8 plus 1 is 9. So 97 equals c squared. So c is the square root of 97, which is making that c is about 9.85 units. Okay, you need to finish numbers 4 and 5. Show them to me before you may move on to your exit ticket.